this is Lauren Retros, and today I'll be solving heat transfer problem 1.27 from the 8th edition of Fundamentals of Heat and Mass Transfer by Bergman and Levine. 1.27 states a vacuum system, as used in sputtering electrically conducting thin films on microcircuits, is comprised of a base plate maintained by an electrical heater at 400 Kelvin and a shroud within the enclosure maintained at 97 Kelvin by a liquid nitrogen coolant loop. The circular baseplate, insulated on the lower side, is 0.3 meters in diameter and has an emissivity of 0.25. How much electrical power must be provided to the baseplate heater? At what rate must the liquid nitrogen be supplied to the shroud if its heat of vaporization is 125 kilojoules per kilogram? To reduce the liquid nitrogen consumption, is it possible to bond a thin sheet of aluminum foil with an emissivity of 0.09 to the base plate? Will this have the desired effect? So, first, we're going to list our givens. The temperature of the base plate is 400 degrees Kelvin. The shroud temperature is 97. The diameter of the base plate is 0.3 meters. The emissivity of the base plate is 0.25. The heat of vaporization is 125 kilojoules per kilogram, and the emissivity of aluminum foil is 0.09. Next, we'll list what we want to find. First, we need to find the necessary electrical power. Then we need to find the rate at which liquid nitrogen is supplied. And finally, we need to determine if adding aluminum foil will reduce the liquid nitrogen consumption. So here is a simple diagram of our system. Now we can list all of our assumptions. First is a constant isotropic properties, steady state conditions, no heat transfer due to conduction or convection, and no energy is generated or stored within the system. Now for our general equations. First of which is the equation for the heat transfer rate of radiation, and our heat transfer rate of nitrogen using the mass flow rate and the heat of vaporization. Now we'll move on to the solution. First, we'll use the heat transfer rate of radiation to figure out the amount of electrical power needed for the system. Both are measured in watts, and since there is no other method of heat or work being done on the system, all the energy will come from the electrical input. So subbing in the values yields a heat transfer rate of 25.56 watts, which is the necessary electrical input. Next, we need to solve for the mass flow rate of liquid nitrogen. We can set heat flow rate due to radiation equal to the heat flow rate due in the shroud, and therefore equal to the mass flow rate and the heat of vaporization. And rearrange for m dot. After subbing in our terms, we get an answer of 2.04 times 10 to the negative 4 kilograms per second. To figure out if the foil will have the desired effect or not, we need to go through the whole process again, changing only the emissivity. This yields 9.2 watts. We can then sub that value into our equation for m dot, which yields 7.36 times 10 to the negative 5 kilograms per second. This is a smaller value than the previous answer, so the addition of aluminum foil to the system would be beneficial in reducing the amount of liquid nitrogen consumed. That's it for this video. Thanks for watching.